All right, students. So let's try this again. Hopefully we won't have any baby babbles in the background. Sorry about that. I have been coughing a lot. I promise I don't have corona. But I apologize if I start coughing. So let's balance our redox reactions. We're going to do this by the half reaction method. So we're going to take our reaction and we're going to break it up into two half reactions. One will be an oxidation reaction, one will be a reduction reaction. These half reactions will include electrons. So if it is an oxidation, that means it's lost its electrons. That means the electrons will go on the product side. So you'll add whatever electrons to the right side of the reaction. If it's a reduction, it's gaining those electrons, so it will be a reactant. You then need to balance each half reaction for its atoms. So let's say you had 10 neon on the left, you need to make sure you have 10 neon on the right. Okay, just making sure your atoms are balanced. You then need to make sure your electrons are balanced on the left and the right, and that they are equal between your half reactions. So here's the actual steps. Let's follow these steps. So I recommend that you have these steps out when you try to do your problems, so that you can make sure you're doing it right. The biggest, most important step is step number 1. It's assigning the oxidation states to determine which element is oxidized and which element is reduced. Okay, this is very important. I have a lot of students that end up putting wrong charges, and that messes up their whole reaction. So make sure you get step number 1 right. Step 2 is to write your half reaction. So write one that's oxidation and one that's reduction. You could then include the electrons here. It's a little bit easier to do it a little bit later, but we'll look at that. Just remember, if it's oxidation, it's losing electrons. So the electrons should be on the right. If it's reduction, it's gaining those electrons, so it's going to be on the left. Balance then by mass. So as I said, if you have 2 nitrogen on the left, you need to make sure you have 2 nitrogen on the right. Okay, so you're going to do that for all of your elements except hydrogen and oxygen. So you're going to save hydrogen and oxygen for last, to do everything else first. Then you're going to add water wherever you need oxygen. So if even though you need oxygen, you're not just going to add oxygen, you're going to add water. Then, since we added water, we're probably going to have extra hydrogens right on one side. So you need to add H+. So anywhere you need a hydrogen, you're going to add H+. If it's an acid, that's okay. We can have H+ in solution. But if we're doing this in a basic solution, we can't have H+ floating around, okay? Because that's only for an acidic solution. So we would need to add OH. We would add OH to both sides such that we are neutralizing the H+ anywhere we have it. So if we have an H+ and an OH, right, that would make water. So that would neutralize our H+. Then we're going to balance by charge. So we're going to adjust our electrons. So if we have a charge on the left of +2, we need to make sure the right is also +2. Okay, if the left is -3, we need to make sure the right is -3. We just need to make sure everything always balances. Then we're going to balance our electrons between our half reactions. So if your oxidation reaction has a -2 electrons and your reduction reaction has -3, you need to make sure they're the same. You would make each to have 6 electrons. And then you would add your half reactions together. That would make your electrons cancel. And then you should count. Make sure you have balanced it correctly. You would count all of the atoms and count your charge. So let's try this first one. It says balance the redox equation. First, let's look at this. Okay, I can automatically tell it's not balanced because on the left, I have a +2 charge. All right. On the right overall, I have a +3 charge. So that is not balanced. This is an acidic solution, so that does make a difference when we get to our hydrogens. In this case, there aren't any hydrogens, so it's actually not going to matter. First step, though, assign oxidation states. So aluminum's a free element. Its oxidation number 0. Copper has a 2+ charge. We're going to use the ions charge, so it's going to be a +2. Aluminum will be a +3. Copper will be a 0. So assign those oxidation states first. Then let's look at the change. What happens? This aluminum goes from 0 to +3. So it has been oxidized, right? It's lost electrons. It's technically lost 3 electrons. Copper 2+, it's gone from +2 to 0. So it has gained 2 electrons. Remember, electrons are negative in nature, so it is a reduction reaction. So you would write those half reactions. You'd write oxidation, right, would be the aluminum solid, yields aluminum 3 plus. Reduction would be copper 2 plus, yields copper solid. So everything up here goes down here, right? We're just separating the 2 reactions. Now we just have one that's oxidation and one that's reduction. Then you need to balance with respect to mass. So we're going to balance all elements other than hydrogen and oxygen. They were actually all balanced if we went back. Let's see, we got 1 aluminum on the left, 1 aluminum on the right. 1 copper on the left, 1 copper on the right. So we are good. The next step is to make sure everything is balanced. So let's look at this first reaction. On the left over here, this is a 0 charge. So that means on the right, we need to make a 0 charge. Well, it had plus 3. So the only way to make a 0 charge would be to add 3 electrons. So 3 positives plus 3 negatives, this is a 0 on the right. So we have 0, 0. Good. Our second one, we got copper 2 plus on the left, right? So we got a 2 plus charge over here. We have a 0 charge over here. So we're going to add those 2 electrons over on the left. Okay, this is a reduction. So reduction, gaining electrons, it goes on the left. So make sure your electrons are on the left for reduction. So we're only adding negative charges, right? We would add them wherever we're trying to balance. Now, we've done it with respect to charge on both sides, but now we need to make sure that each of the reactions are the same. This first one has 3 electrons, our second one has 2. So let's multiply our first reaction by 2. So let's multiply everything by 2 to get this reaction here. Our second reaction, our reduction reaction, we're going to multiply everything by 3 to get this reaction here. So now our top reaction has 3 electrons on the right, or 6 electrons on the right, 6 electrons on the left, right? When we add them together, we'll see that these electrons cancel. Because we have 6 on the right of the arrow, we have 6 on the left of the arrow, they cancel each other out. So now we just add everything on the left side of the arrow together, everything on the right side of the arrow together. We have this new equation. We then do need to check. So this should be the answer. Let's check. You need to make sure everything is the same on both sides. So let's look. We have 2 aluminums on the left. We have 2 aluminums on the right. We have 3 coppers on the left. 3 coppers on the right. Our charge, let's see, on the left, we have copper 2 plus, so there's a 2 plus charge, but we have 3 of them. So we have a plus 3 on the left. On the right of the arrow, we have a plus 3 over here, but we have 2 of them, so we got plus 6. So both of these are plus 6. So our charges do balance on both sides. So this is how we would balance in an acidic solution. So I want you to try this one. This one is a little bit harder because it does have hydrogens, but we can have H+. Since it's acidic, we can have H+ as one of our final answers. But go ahead and try this. Balance this reaction. So pause this video and then check. Make sure you have the right answer.